Hello, greetings to you all once again, and welcome to the last tutorials on calculus videos, right? So we are going to do the last tutorials. Okay. So today, what we are going to talk about is the integration by parts. Okay. So after watching this video, if you have any question under integration or differentiation, you let me know. Okay. If there's anything that I need to do, right, which I didn't consider in all my videos, you let me know so that we will discuss it. Probably maybe you want some explanation to certain things, so you let me know. Okay. And if you are sending me questions, please try as much as possible to solve something, do something on a paper, right? So once you do it, then I'll verify so that I can pinpoint the mistake. Don't let me solve everything all over again, right? I'm pleading with you. Try to show something that, oh, this is what I've done, and I'll be able to explain to you what you need to do and where you need to go. Okay. So please try as much as possible to subscribe to my channel. Thank you all for following me to this point, right? And also join the Telegram page where probably we'll be talking about some questions, motivation for the exams, and other stuffs. Do you get it? So I wish you the best of luck in your exams with this last video on calculus. This week, right, I'll start the video on semiconductors, and possibly I'm going to complete everything latest by, let's say, Monday. Do you get it? Yes. So let's just jump into the video. I'm going to talk about integration by parts. Okay, so you can recall, let's just jump into it. You can recall that when we were doing the quotient rule, right, we said that d on the x, right, of, let's say, a function u of v, right, then it's going to be what? It's going to be v du on what? On the x, right, plus u what? The v on the x. Do you get it? Let's make, how do you call it? V du on the x the subject, or let's say, let's make u the on the x the subject over here. So with this relation, if I should make u the on the x the subject, then what do I get? I'm going to get d on what? On the x, right, u v minus v du on what? On the x, right, equals u the on the x. Yes, I've made u the on the other subject. So let me rewrite it again. I always prefer bringing the u the on the x at the left hand side, or let's say right hand side of the equation. So this one can also be written as u the on the x equals to what? D on the x of what? Of uv, right, minus v du on what? On the x. Very good. So assuming we are integrating all side with respect to what? With respect to the x, integrating, right? So if you should integrate this side, u the on the x, right, with respect to what? X, that is the x. Then integration of d on what? On the x, uv, right, with respect to what? The x, minus integration of what? V du on what? On the x with respect to what? The x. Now what do we get? If I should integrate this side, right, I'm going to get, let's say, u the, or let's better still, let me say that the x can cancel the x here, right? So I'm going to get u the, right, equals to, and at this point, if I should integrate, right, I'm going to get, let's say, uv, right, then minus, if I should cancel out the dx and the dx, right, I'm going to get integration of what? V du, right, and this gives the general formula for finding the integration by parts. So if you know this formula, then it means you are 90% done with your work, right? You always need to select the u and what and the v, right? You always need to select the u and the v, or the v, sorry. So you always need to select the u and the v when the question is given. And with that, we always prefer using the lets, right? Or the eyelets, sorry. So the eyelets, right? And the L here stands for log. This one stands for inverse trig. Inverse trig, right? And this one stands for algebraic expression, right? Algebraic expression, like algebra, right? So algebra, right? Any algebraic function in it. Or let me go algebraic function, right? Then this stands for trig, normal trig. Then this is exponential function. Exponential function, right? And this one too is the same thing, but it's just that the inverse log is moving, or inverse trig is in the first, or is starting instead of the log. We get it. Then we also have the algebraic function. Let me just write algebraic, right, and put f there. Then we have the trig. Then we also have the exponential function. So the difference is that with the first one, L is starting, that the log is starting, and I is starting. Normally, the most popular one used is the length, right? But as research went on, people discovered that no, the inverse trig should come first. So most of them are good at the late. So you always try to stick to the late when you are solving questions, right? But there are some exceptions, right, which I'm going to talk about at the last end of my video. When late does not use, or where we don't use the late or the eyelid, right? There's a condition where we doesn't use all these two formulas, right? And I'm going to expose you to them so that when you get those questions, you don't actually start with integration by parts, but you look for another method in solving it. You get it? And if you are using integration by parts, you need to be vigilant. Those ones, if you've not solved them before, it will be very difficult to get the concept, right? So let's keep on going. So these ones are just to select the u and the v in the question. So let's first move towards example 1, right? Example 1, right? Assuming I'm asked to integrate, let's say, ax, right? Sine, no, let me look for something simple and not complicated, right? So let me start with something so simple. Once we move deep, then we will be moving to the complex ones, right? So assuming I'm asked to integrate 3t e exponent exponent 2t, right, with respect to the t, right? So with this one, I need to first know my u and my v. So I use the length, right? So with this, we have exponential function as last. So in that case, 3t is an algebraic function. So the u is going to be 3t, and the v will be will be the e exponent 2t. Very good. So now that we've gotten it, we just write our solution. Then we state that let u equals to is equal to 3t, right? So with this case, the u on the t, right, the t will give us 3. Okay, so if I should make the u the subject, I'm going to get the u equal to 3 dt. Yes. So we are going to also let v or the v, right, equals to what? Equals e exponent 2t. So integrating both sides, that is the v equals to what? The integration of e to t with respect to what? With respect to t, that's the t. So if I should simplify this, what do I get? I'm going to get v equals to what? I'm going to get e to t divided by what? 2. I made it clear to you that during integration, right, normally we differentiate what is up there. That is, if I have e to t here, I differentiate what is up there. It becomes a fraction. That's 1 over 2. Then I just repeat the e to t. So that's the reason why we had e to t divided by what? Divided by 2. So I think it better explain it. But if you are struggling with it, please try as much as possible to watch the previous videos. Then you will be fine. Okay. So now that we've gotten all our rows, we can just state the formula. And what the formula states? The formula says that the integration of what? U div, right, equals to what? Equals u v minus integration of what? V du. Okay. But here, what was our u? U was the same as what? 3t. And how do you call it? The div was given as e2t. Let me put the dt here so that you will not be confused. Right. So the div is given as e2t dt. So if I should write it here, that is integration of what? The 3t. Very good. So 3t e2t what? dt is given as, what was the u value? The u is 3t, right? So we have our 3t here. And what's the v? The v is given as e2t divided by what? Divided by 2. So multiplying what? e2t divided by 2. Then we have minus, what was v? V is given as the e2t divided by 2 again. So integration of e2t divided by what? 2. And what was our du? Du was given as 3 dt. So we just put our 3 dt here. Multiply by what? 3 dt. I think we are good to go. Yes. So at this point, we can now simplify. Right. So with the first one, you are going to get 3t e2t all divided by what? By 2 minus, I'm going to bring the 3 on 2 out. Integration of what? e2t dt. Very good. So at this point, what do we have here? Let me repeat this one. 3t e2t on 2 minus what? Minus, if I should integrate this, I'm going to get e2t divided by 2. So 3 on 2 into brackets e2t divided by what? 2. Right. Then I'll get my plus c. Very good. Yes. So what do we have here? I can simplify. That is I'm going to get expanding the 3 on 2 out. So if I should expand 3 on 2 out, I'm going to get, then I'll also bring e2t out. So I'll have 3e2t all divided by what? By 2 out. And once I do that, it will be left with t at the first term, then minus. Now what will be left over here? We are going to get the et. No, we are going to get 1 on 2. Very good. So we are going to get 1 on 2. Well, the et is already out. I'm just going to get half 1 on 2, right? Plus c. And that is the final answer for the first one. Okay, so let's proceed to example 2, right? Example 2. And the question is asking us to find the integration of what? X cos x dx, right? So at this point, we write our LIATE, right? So with this, the algebraic function comes first, then the trig comes second. So our u is giving us x, then divin is giving us what? Is giving us, how do you call it? Cos x dx, right? So we move on to solution. We are going to let u be equal to what? X. So in that case, the u on what? On the x is equal to 1. So making the u the subject, we get the u is equal to what? The x. Very good. Then we are going to let the v represent what? Cos x dx, right? So we integrate both sides. That is the v and integration of what? Cos x dx, right? So with this, I'm going to get v is equal to what? Minus sine, right? So if I should integrate sine, I'm going to get minus cos. So if I should differentiate sine, I'm going to get what? Cos. So if I should integrate, how do you call it? Cos, I'm going to get sine, right? I'm going to get sine x, right? You should take note, these things, they are quite confusing. So we'll make sure that you don't escape them. When you are writing your exams, take your time and develop a formula that will not confuse you. Okay, so now we've been able to find our u and v. So we can just write the formula. Integration of u dv is equal to what? Uv, sorry, I've made it x. The integration of u dv, right? What? Uv minus what? The integration of v du. Very good. So now we can just substitute. So what do we have? The u was giving us x. So the right hand side is more like the same question. And the dv is cos x dx. So you can see that it is just the repetition of the question. Okay. So it's equal to, what is u? U is giving us x. And v is giving us what? Sine x, right? Then we have minus integration of what? Sine x. Then the u is simply dx. So you just write the dx. And what do we have here? You are going to get x sine x, right? Right. Minus into bracket. If I should integrate sine x, I'm going to get minus cos x, right? So yes. Then I'll have my plus c. So at the end of it all, I'm going to get x sine x plus what? Cos x, right? Plus c as the final answer. Do you get it? Let's move on to the next example. That is example 3. I think let me solve the last example. This one is very, very simple. Once you get the formula, you are good to go. So there's no big deal in this. Let me solve the last example here. Then I'll show you the rules in solving the, how do you call it? The integration by parts. The exceptions, right? Which I made it clear to you. The exceptions with integration by parts. So if, let's say, I have the question to find what? To find the integration of root x ln x dx, right? So with this, what is going to be u? I have LIATE. So with this, the log function is going to be first. Then we have, how do you call it? The algebraic expression, which is the second. So we are going to make u represent ln x. Then we have div representing what? Roots x dx. Very good. So now we can proceed by solving. Solution. So if u is equal to what? Ln x Then the u on what? On the x is going to be what? So what we do is that we integrate what is inside, we differentiate what's inside, then it becomes a fraction of it. So this one is simply going to be what? 1 on what? On x. IAK, that is ln x. But the main rule is that we differentiate what is inside. So differentiating what is inside gives what? 1. Then we write what's inside as a fraction. So when I simplify, I'm going to get 1 over x. So that is the rule. Normally when you are solving simple questions, just still apply the rule, because you don't know when you forget how to apply it. Are you okay? So at this point, what is going to be the result? That is, if I should find the x, that's the u. The u is going to be what? 1 on x dx. Very good. Now let's talk about the v. The v is equal to what? X exponent half dx, right? So let me integrate both sides. The v is equal to what? Integration of what? X exponent half dx. So at this point, we are going to get v is equal to what? I add plus 1 to it. So let me add it straight away. The integration of, no, we are not going to add integration again. We are going to get v is equal to x 1 on 2 plus 1 all divided by, so 1 on 2 plus 2 on 2 is going to give me 3 on what? On 2. Very good. So I'm going to get 1.5, which is 3 on 2. I'm going to get 3 on 2 here. So what do I get? What is v? V is simply going to be what? X exponent 3 on 2 times what? 2 on 3. If I should simplify, that's reciprocal. So at the end, I'm going to get 2 square root of x cube all divided by what? 3. So that is going to be the value for the v, right? So at this point, right, at this point, we are now going to use the formula. That is, integration of u dv is equal to what? U multiplied by v minus integration of what? V du, right? So the right hand side is basically the question. That was ln x. Then we have root x. So ln x was the u. Then we have root x dx, right? Okay, so it's basically the same thing. Root x ln x dx is the same thing. So we are going to get, what is the value for the u? U is given as what? Ln x, right? Then we have our v. V is given as 2 root x cubed all divided by what? 3 minus, then we have the integral of, what is v? V is given as 2 root what? X cubed all divided by 3. Then what was the du? Du is given as, du is given as 1 on what? On x dx. Very good. So now it's left with us to simplify this. So what do we have? We're going to get our ln x multiplied by our 2 roots x cubed on what? On 3 minus, I can bring the 2 root 3 out. Integration of what? X exponent 3 on what? On 2 divided by what? X dx, right? Very good. So can we do any simplification? Yes, we can do simplification here. This is the same as x 3 on 2. That's, I'm using lots of indices. I can do cancellation, but I'm using lots of indices. Multiply by what? X exponent what? Minus 1. Right. So I'm just going to say x 3 on 2 minus what? 2 on 2 here. Right. Then at the end, what do I get? I'm going to get 1 on 2. If I simplify, I'm going to get half. Right. Yes, I believe I'm good to go. Yeah, so at the end, it's more going to be ln x multiplied by what? 2 roots x cubed, all divided by 3, all divided by 3 minus 2 on 3, right? Integration of what? X exponent half dx. Yeah, so what I'm trying to say is that with this side, if you don't understand, we can reverse the video to explain yourself very well. This expression here, let me use a different ink. Probably maybe someone will be confused with it. So I'm going to explain myself very well again. This expression here, right, can be written as x exponent 2 and 3 multiplied by what? S exponent 1. Then lots of indices gives me what? X 3 on 2 minus 1, right? And the 1 here is equivalent to 2 on 2. I write my 2 on 2 here. So if I just simplify, I'm going to get x exponent what? 3 minus 2 gives me 1 divided by what? 2. That's the reason why I had this. So it's nothing different. Are you okay? So let's proceed. So we have our ln x multiplied by what? 2 root what? X cubed, all divided by 3 minus 2 on 3. Then if I should integrate this, what do I get? I'm going to get x 1 on 3, 1 on 2, sorry, plus 1, which is the same as 2 on 2. I always want the denominator to be the same. That's why I always find the equivalent fraction. So 2 on 2, all divided by what? And this gives me 3 on 2. If I should sum them up, I'm going to get 3 on 2. Right? Then I'll have my plus c attached to it. So what do I have? I'm going to get ln x multiplied by what? 2 roots x cubed, right, all divided by 3, right, all divided by 3, then minus 2 on 3 multiplied by what? X 3 on 2, right, times 2 on 3, the reciprocal of it, plus c. So we are getting like 2 and 3, so 4 on 9. We are going to get ln x 2 on 3, 2 on s cubed, all divided by what? 3 minus, then if I should multiply, I'm going to get 4 on 9, right? 2 times 2 is 4, 3 times 3 is 9. Then I'll get my square root of what? X cubed, right, plus c. Can I factorize something out? Yes, I can factorize something out. That is, I can factorize 2 on 3 root what? S cubed out. And if I do that, I'm going to get ln x for the first one minus, I'll get 2 on 3 here, and that's all. Yes, 2 on 3. Then finally I add my plus c. Okay, very good. So that is it for the example 3 also. So I'm going to talk about the exceptions of, how do you call it? The LIATE, the late rule, or the ILATE, right? For it, before I do that, let me solve that example. Let's say example like 4, right? So let's assume I have something like, find the integration of what? X cubed e x squared, right? With this, let's use the let and see how we will choose our u and our dv. So with this, you say that algebraic comes first, right? Algebraic function comes first. So I would have said that u is equal to what? S cubed. Then the dv is equal to what? EX squared. If you choose this and you solve with it, you are going to get it wrong. Right? So you always need to be careful. There are some exceptions with the integration by parts. So you always need to be careful with it. So with this one, I'm going to let u be equal to what? X squared. Right? Then, in that case, the u on the x is going to give me what? 2x. Right? 2x. Then, that's it. Very good. So, at this point, we are going to get the u is equal to what? 2x dx. Right? Then, what again? If I have div, what is div? Div is going to be what? X e x squared. Right? So, if I should integrate, this integration is going to be quite complicated. So, integration of what? Div, that is with respect to dx. Right? Integration of div and integration of x e exponent what? X squared with respect to what? The x. Right? So with this integration, how do we do it? We are going to use integration using algebraic substitution. Right? So what do? We are going to write the coefficient x. Then we divide by the differentiation of the x squared. So that will give us 2x. Right? Multiply by what? E. Then you rewrite this one again. X squared. You get it? So x cancels x. So at the end, what do we have? We are going to get e x squared all divided by what? 2. That is integration by algebraic substitution. If you are struggling with it, please visit my previous video and you understand how to do integration by algebraic substitution. Okay, very good. So at this point, we've been able to find our v, we've been able to find our u, and we've been able to find our div, and so on and so forth. So what do? We are going to write the formula. That is integration of u v is equal to what? U div, is equal to u v minus what? Integration of what? V du. Right? So this one is basically the same as the question, which is giving us integration of what? S cube e x squared what? Dx. Then what is u? U is giving us x squared. We are going to get x squared here. Then what is v? V is giving us e exponent s squared all divided by what? 2. Right? Minus, what about v? That is integration of e exponent s squared all divided by what? By 2. And the du was giving us 2x dx. So multiply by what? 2x dx. Right? So the 2 cancels the 2. Are you okay? So once we're able to do that, we can say that x squared e exponent x squared all divided by what? 2 minus integration of what? X e x squared dx. Do you get it? So at the end, what do we have? We're going to get x squared e x squared divided by what? 2 minus. Then what do we have here? Integrating this, I hold the x. I differentiate the s squared, giving me what? 2x. Right? Multiply by, I write the same thing. E exponent what? S squared what? Dx. No, I don't add the dx to it. I've already integrated it. So at the end, what do I get? Plus c. So something like this. Then I have my plus c to it. So at this point, I'm going to get x squared e s squared divided by what? 2 minus x. The s cancels the x here, right? So you don't need to write the s again. So minus, right, e s squared divided by 2 plus c. Okay, very good. So what do? We can factorize. We can factorize e s squared divided by 2. or into bracket hot. Then what do we have? It will be left with s squared at this point minus half. Very good. No, not minus half, but minus 1. Sorry. So minus 1. Right. Then we have our plus c attached to it. So that gives the final answer. So you see, with this, when we are solving, we didn't use the LIATE. So there are some exceptions, right? What are some of the exceptions? I've written all of them. So when can we avoid the let or islet rule? So when to avoid the let or islet rule? Let me write there. So when to avoid, right? So when to avoid the what? The LIATE or ILATE rule. So when do we avoid it? The first one, when both functions, right, are exponential. So when both functions are exponential, we don't use it. Example, if I have integration of what? Integration of e exponent what? X, then e exponent 2x dx. We don't apply it. Okay, so number 2. When should we avoid the LIATE or ILATE, right? When both functions, right? Both functions are trigonometric, right? When they are trigonometric functions, right? For instance, example, if I have integration of what? Sine x, right, cos x. So with this one, I've talked about the trick. You can apply the trig rules to get your final answer. Yes. So the third one, when should we avoid? When they are non-standard forms. Non-standard forms. You get it? They don't follow the exact formula, like what I wrote, right? Okay, even before I move on to them, it's more like this example, like integration of what? 1 on x ln x, right, dx. So they are of non-standard forms. So once you can use integration by parts, but you cannot follow the LIATE rule or ILATE rule. Okay. Then the last one that I'll talk about is when we have a complex nested function. Complex nested function. Right. And example is what? Is integration of what? Sine x e what? X squared, right, dx. Or what I just solved, the question I just solved over here, which was integration of s squared e x, integration of s cubed e x squared, or integration of what? S cubed e x squared dx, right? So this is more like complex nested function. So you need to avoid these ones. So these are the rules, right? The condition to avoid the LIATE and what? The late. So ILATE, sorry. I'm quite tired. So that is the rule, right? So please try as much as possible to avoid the formula or the rule when you are using it. You can apply integration by parts. There's no doubt. If I want to solve integration by part with this, probably I can do it. And even this one is more like I can just use simple integration to solve. I can just say that integration of what? e exponent what 3x dx. So it's very easy to solve, right? But you cannot apply integration by parts. And this one too, I can use the trig function to solve this, right? And this is going to be quite complicated. I'll prefer integration by parts, but it will be quite complicated to solve over here. I might spend more time, so there's no need for me to solve. I've already solved this, and this one too, using integration by parts will be possible, but using the LIAT rule or ILAT rule will not hold. You are going to get an error if you apply it. Please. So how you get to know this is applying what practices, like performing constant practice. So solve more questions, and once you solve more questions, you'll be able to find your way out. Okay, I wish you all the best, and I've ended my calculus video. So I'm going to move towards semiconductor this week. I'll try to finish semiconductor this week, and next week you'll be able to prepare and write your exams. I wish you the best of luck in everything. Bye.